probably have to introduce myself. My name is Eugene Seah from Langdon and Seah, Singapore. And a couple of months ago, I was invited by Dr. Junit to write a paper. Thank you very much. On the for this conference, and I told him that, are you sure? Because everybody will be either an architect or an engineer. And I don't have nice, fanciful cross-sections and plans as what you saw the previous two speakers actually showed you. So he said, no, never mind, just try your best. And I did try my best until yesterday. I was in the lift with an architect from Chicago and introduced myself. Hi, my name is Eugene, and I'm a quantity surveyor. He looked at me and glared and said, I want to hold you to that. So I got a bit worried, and until today, just before I came up, Jerry actually mentioned cost 10 times in his speech. So I think I do have, as quantity surveyor, a good value in tall buildings. So my talk today is on capital cost drivers in tall buildings. And as a firm, we have a group of people that looks into cost economics and sustainable economics on tall buildings itself. So I'll be looking at probably 3 or 4 major factors and looking at the social economics portion in tall buildings as well, and looking at the benefits and the triple bottom line. Quantity surveyors are always thought to be people in the project team that likes to cut costs, and in this case, to have a square building. Pardon me, I couldn't find a square building, so this was the best I could to get. So I would like to change that thinking to say that, quantity surveyors are actually there to embellish design. We're there to make sure that the dreams of the architects and engineers are portrayed and built, but at a cost-effective and of value for the project. So there are tall buildings, as I think so far the presentations has showed you that there are several things to consider. For example, wind load, the weight of the building, structures, the MEP, simulations. So these, to me, are also cost drivers. For example, the taller the building, we have to start looking at the columns, the foundations, diaphragm effect, in terms of connectivity of the towers, and all these are cost drivers itself. Now back home, there are government land sales tenders, and when clients want to go and bid for this land, they literally just give me a piece of paper with the data sheet, and I have to cost and give them a budget, construction budget of this of the building. The first question I always ask them is, may I know who is your architect? And they ask me, will that make a difference? I said, oh yeah, of course, because if you do have an architect that comes back with that you need a diagrid system, for example, cost will be very, very much different. So we need to start looking at how, matching in terms of design by the architects to that of the total construction cost. So generally, taller buildings, as opposed to shorter buildings, would be more expensive. How much more? It can be about 10 to 20%, depending on the type of design and the foundations used. So a typical tall building, as you can see here, in Singapore, you have things like sky gardens, sky terraces. You have a courtyard. You have probably a podium system, and right now back home, you also can have 10% of the area that for balconies. Now, all these areas, for example, like the sky court and sky gardens, are not considered as gross floor area. So developers may not look at that as cost, but you need money to build this. You need money to build the columns. You need money to build the courtyard and the softscape. All these do add up to cost, but they add value. For example, sky court, sky gardens, they promote social interaction, social connectivity. I believe on Friday you will hear a talk by 2 Singapore architects on the Duxton, whereby they have sky courts and sky terraces that link the four or five different HDB blocks together. So that has a use. So there's not always a case that you need to do cost cutting and the design comes out bad. So one of the key cost drivers will be the facade of the building. It can be 15 to 20% of the cost. I have seen systems, a triple skin wall, where it's about 25, right? But there was a reason for that as well, because They wanted it to have an iconic design as well as photovoltaic cells plastered on the facade. So in terms of tall buildings, facade cost is something that we need to look at. But how do we look at it as quantity surveyors? Well, I sit very closely with the architect and carry out cost-benefit analysis, for example, on the shape of the different buildings, even at massing stage. And I come up with a table, right? We have a cost model here, projecting in terms of the shape of the building to find out what will be the optimum and best design for the facade with sustainability in mind, for example, in sun shading devices as well, and come up with the optimum shape. There's this thing that we look at called the wall-to-floor ratio. So I'll give you an example. A 20 meter square can be achieved with a 5 meter by 4 meter, but that means your perimeter is 18 meters. 20 meters square can also be achieved by a 10 meter by 2 meter, but means that your perimeter is 24 meters. The 10 by 2 meter square building will cost slightly higher, about 6% higher, because of the shape. So these are some of the considerations, even as quantity surveyors, I need to take into account just by the shape of the building or even by the design. BIM has come into play as what I think some of the speakers actually spoke about. So what we usually do is also sit together with the design consultants to work up the BIM model, and very early in the stage, we need to talk to them. What type of material are they going to be using? What type of design are they going to be using? This was a study that we did with HOK, and very early in the stage, during the massing plans, we already were looking at the twisting of the towers. And this is just one case study whereby if the areas are all the same, but the external wall of the building is different, you'll find that option A, in terms of the wall-to-floor ratio, in terms of construction costs, should come in lower than that of B and C. Right? To me, I think all the buildings look the same. But I think to an architect, probably there will be a difference. But in this case, A will come in much more cost-effective. In terms of facade as well, on sustainability, we sit down with the ESD consultants, the environmentalists, and to study, just one example would be the sun shading devices. Okay? So this is a situation whereby we would like to find out what is the optimum sun shading device that you need for a building. Some designs coming at 1.5 meters, some are, they have the sun shading devices offset by about 1 meter from the facade. Singapore, we have the sun at 12 o'clock high. So if you use softwares like Ecotech, you will find that the optimum amount size of the sun shading devices will be about 800 mm. Okay? So 1.2, 1.5 is actually, in this case, can be considered as a functional overkill. I've also carried out some studies to find and found out that if the sun shading devices are pegged exactly where the skin of the facade is, versus if it's offset by 1 meter. If it's offset by 1 meter, it's only 30% effective. But if it's abutting the facade, it's 80 to 85% effective. So some of that goes to show that if you have facades that are jutting out from the, or there's a second skin, for example, is jutting out from the main facade, that may not be that effective as a sun shading devices. Architecturally, you may look all right, but in terms of its functional use, questionable. I mentioned just now about sky gardens and sky terraces. These are non-GFA areas, but they can be quite costly, and this is some of the designs that we have back home, whereby it's almost like a vertical green. In fact, I was sharing some design by Toyo Ito on Capita Green in Singapore. It's the Old Market Street project, whereby 60 to 70% of the facade is going to be green. So it's going to be look as though it's sucking the entire greenery from ground all the way to the facade, all the way to the roof. So in terms of having these areas, to me, it's important because it promotes social interaction. It can be used as a sun shading device as well. But building these areas, there is, you can do it very cost effectively. And for example, this will have a consolidated cost about $25 per meter square versus that of a built-up roof that can be about $300 to $500 per meter square. So we need to work very closely with landscape architects, in the beginning of the day to find out how we can green such spaces cost effectively. One thing to consider is also maintenance, because if you have too much greenery, maintenance can be a nightmare. So the benefits of green building, from where I stand, I was just interviewed this morning by Jeff, and I shared with him that in terms of where we observed there's higher occupancy, higher productivity, and higher yield. LEED has done a study, and they have shown that there's even better yield rate in terms of green buildings in America. Okay, but we have to recognize that there is a premium to pay for really green buildings, for example, like platinum buildings. Sometimes I'm given a challenge by the client to say, this is your budget, I want a platinum building, go with it. So it's going to be quite challenging, because if you want to have a platinum building in Singapore, for example, we need to achieve a minimum of 30% energy saving from base. There's quite a lot of work to do. We have to work with the facade, we have to work with the ACMV people, the electrical, just to come together to get the platinum building built. So one thing that we also look at is this thing called life cycle costing, whereby we try to prove by calculation to the developer to say that, look, you may need to spend a little bit more money, say 3 to 5% more on a certain product, but you have a 2.5 year payback, and the rest will be savings to you. So this is to the life cycle of the product, or at the end of the day, if you use structural steel, for example, you'll be able to recycle this steel for another building, and it's going to be 1/3 the carbon, and also cheaper, in this case, half the cost. This is one of the studies where we look at on the cost-benefit analysis on a certain product versus that of the different internal walls. Now, this is a true case study where I was trying to tell the client that, look, if you try to use a green wall, for example, it's a low-carbon wall, it's very buildable, two people can handle it, and the cost per meter square is lower or the same cost as brick walls. In Singapore, we have this legislation called buildability scoring, and this will get green wall will get you your 2 points, but the rest will not, because it's not buildable. It takes more people, 5 to 6 people, just to do the same work of 2 people if you use this wall. So such studies that can be carried out by the quantity surveyor in conjunction with the design consultants is very important, because it validates material use and validates design. It's a new thing that's happening in Singapore now is on productivity and space planning. Buildings are built, purpose-built buildings are built, pre-engineered buildings are built for the developers, whereby you can look at, so studies have been carried out, for example, if you have a central core versus a side core, looking at depth of space, adjacencies, and even quality of space. This actually can impact on sustainability as well, because if you have, for example, a side core, ETDV, the envelope thermal transmission value will be lower, versus that if it's cladded 4 sides with glass. But in terms of usability, if you have a front of house area, which is greatly used in area C, for example, and a back of house in A, this would suit better. But if you want to use multi-tenanted use like this, then a central core is better. So there is a there are pros and cons that we need to weigh and sit down with design consultants to come out with the best design for tall buildings. So this is, while the movie is playing, this is a model which I created in Singapore. It's a triple bottom line, right, whereby you have environment, economics, and social coming together on sustainability. And design consultants, whatever building, we have to look at buildability, productivity, constructability, even safety, Workplace Safety Health Act, and supported by value, BIM, and even Green Mark. Now, looking at the issues surrounding tall buildings like fire, life safety, R&D, advanced structure and design, location, and simulations. These can all come together for tall buildings to support, the triple bottom line. This is just one example of a building that has been built in Changsha, the Hunan, and it was built in 7 days. Right? If you can see, this is the time, this is the number of hours, and you can see that it was actually built in 7 days, closed in 7 days, not including foundations. One of the things that we are also looking at in Singapore is on carbon. And we have clients that are looking at not only operational carbon as a carbon plan, but it's also on looking at embodied carbon. So they will be looking at us to come up with a cost plan, but in relation to the respective carbon that comes together with that material. And we have carried out a carbon plan on some buildings and found that in Singapore, our carbon is about 850 kg per meter square, whereas in the UK, I understand it's about 400 to 500. In Singapore, commercial tall building, you're looking at the carbon at about 1 ton. So there you go. This building was done in less than a week, and it's a functioning hotel. So I think productivity management is something that we have to look at now as well, and it has to be juxtaposed to cost, design, sustainability, and of course the functional use of the building. And I believe that there is room for studies in terms of how you can build faster, better, safer, and with sustainability in mind as well. So in conclusion, tall buildings are able to ensure maximum optimization of land, especially for land-scarce Singapore. And but there are huge capital investments to it. And as quantity surveyors, I believe that cost models are very important, and they have to be worked together with design consultants, and not designed and then give the designs to the cost consultant to work. It has to be done simultaneously, similar to how an architect and a structural engineer should sit together. They form what Bruno Harper calls a archi-structure, whereby you have fantastic structures integrated and woven into architectural designs itself. And of course, if cost drivers and design drivers are observed together, I believe you get a building that's not only cost-effective, but of better value. Thank you very much.